Hello, good evening, sir. Myself Vidya. In this video, we are going to see about the quality of service. So, first of all, the outline: what is quality of service? Basic mechanisms: leaky and token packets, integrated services, differentiated services, economics and social factors facing QoS versus over provisioning. So, best effort versus QoS. So, what is best effort? So, for example, if you get a link to the internet with at most B bits per second, if you don't like it, switch to another provider. So, quality of service: we provide you some kind of guarantees for bandwidth, latency, jitter. So, network is engineered to provide some quality beyond not to exceed B bits per second. So, quality of service cost. The holy grail of computer networking is to design a network that has the flexibility and the low cost of the internet, yet offers the end-to-end quality of service guarantees of the telephone network. So that was said by S. Keshav, and we need to know about the two styles of quality of service. So in everything we know about the worst case and the best case. So here the worst case: provide bandwidth or delay or jitter guarantee to every packet. Example: hard real time. And average case: provide bandwidth or delay or jitter guarantee over many packets, statistical in nature. Example: soft real time. So resource reservation example: SRC 10 Mbps available router, then 4 Mbps available router, then 6 Mbps available after that test. So source attempts to connect to destination and attempts to reserve 4 Mbps for the connection. So this connection was accepted. There is enough bandwidth available. Available link bandwidth updated. Source attempts to connect to destination and attempts to reserve 5 Mbps for the connection. Result: failure. So there is not enough bandwidth available on one of the links. So the resource reservation plays a major role here. Once a connection is accepted, the host must use only the amount of resource reserved. It may not use more than that. So what is if the host is malicious and attempts to use more network resources than it reserved? So for that we use leaky bucket. So used in conjunction with resource reservation to police the coast reservation at the coast network interface, allow packets into the network at a constant rate. Packets may be generated in a bursty manner, but after they pass through the leaky bucket, they enter the network evenly spaced. So the leaky bucket is a traffic shaper. It changes the characteristic of packet stream. Traffic shaping makes more manageable and more predictable. Usually the network tells the leaky bucket the rate at which it may send packets when the connection begins. Policies the average rate. In some cases, we may want to allow short bursts of packets to enter the network without smoothing them out. For this purpose, we use a token bucket, which is a modified leaky bucket. So now we going to see about the token bucket. The bucket holds tokens instead of packets. Tokens are generated and placed into the token bucket at a constant rate. When a packet arrives at the token bucket, it is transmitted if there is a token available. Otherwise, it is buffered until a token becomes available. The token bucket has a fixed size, so when it becomes full, subsequently generated tokens are discarded. So here we show the pic of the token bucket. So we can see the example of token bucket versus leaky bucket. Here we can now see about the token bucket. So now we going to see about the quality of service issues. So there is so much of issues will be also there here, and that all are flow specification, routing, resource reservation, admission control, packet scheduling, RSVP, addresses reservation. So per flow classification. This is an integrated service example data bath. Per flow scheduling. How things fit together. Here in this big we can see that in a clear manner. Then service classes. So multiple service classes are available. Service contact between network and communication client, that is called service. So there is so much of multiple service classes available. End-to-end service, other service scopes possible. So three common services: best effort, hard real time, soft real time. Service contract, network to client, guarantee a determined upper bound on delay for each packet in a session. Client to network, the session does not send more than it specifies. Algorithm supports admission control based on worst case analysis per flow classification or scheduling at routers. So service contract, average case. Now we're going to see about controlled load service in an average case. So in that we can see about the service contract and algorithm support. So then the next thing we going to see about is role of RSVP in architecture. So signaling protocol for establishing per flow state, carry resource request from host to routers, collect needed information from routers to hosts. At each hop, consult admission control and policy module. Set up transmission signaling protocol for establishing per flow state. So we can see the RSVP design features. IP multicast centric design, receiver initiator reservation, different reservation styles, soft state inside network, T couple routing from reservation. So we can see about the big picture here, and this is the big picture too. Then we going to see about the RSVP terminologies. So in this we can see about the route pinning. So that is actually a problem. So asymmetric routes. So you may reserve resources on R, S3, S5, S4, S1, S, but data travels on S, S1, S2, S3, R. Solution: use bath to remember direct bath from S to R. Perform route pinning here. So thank you, sir.